Hello, welcome to my Linux tutorial, and today we are going to talk about an important concept in Linux called the links. We are going to talk about links in Linux. So before we continue, we have to know what inodes are. Inodes, what inodes are. So what are inodes? For every file in our file system, there exists an inode, index node. An index node, you can think of an inode as a data structure or database consisting of the metadata information about the file. What metadata information, you might ask, such as the type of the file, permissions, timestamps, user, and all the kind of the rest. So then let's get back to our main topic, Linux links. So we have two types of links in Linux, namely the soft link and the hard link. The soft link is also known as symlink or symbolic link. So let's talk about the first type, soft link. So the soft link, think of a soft link as a shortcut in Linux, shortcut of an application in Linux. Alright, so let's say you have an app, let's say desktop app, whatever app that you have. So you create a shortcut in documents, or downloads, right? So symlink or symbolic links are very similar to shortcuts in Windows. Let's say we have file 1. Alright, in our Linux system we have file 1. Then we create a symbolic link of file 1 link. What is the content? Like, this is like a pointer to this file 1 with the symlink. Let me show here. It's like pointing to this file 1, in the case of symlink. And again, we can create several symlinks if we desire to. Let's say we have another file 1 link 2, alright, and so on and so on. So just in the case of Windows shortcuts, what if I happen to delete this original file? Will the links work? No. Yes, right? So it is the same in Linux. It will not work if the parent file is being deleted. So we will see this in practice in short, but before then, let's go to hard links. So hard links, you can think of it as a clone or a copy of the original file. Let's say we have file 1 here, and then we have hard link, file 1 hard link. Alright, file 1 hard link. File 1 hard link is not directly pointing here, but rather they share the same inode. So if I happen to remove this file 1, the original file, it will still work, the file 1 link. So this link will still work if I happen to delete this file 1. Okay, in the case of hard links. And again, I can create as much as I desire the number of hard links I need. So let's say file 1 hard link 2, alright, so on, so on and so on. So what is the difference? If someone asks you what's the difference between the symbolic link and the hard link, so in the case of symbolic link, this has its different inode number, this has its different inode number. So if I change the and they point, they are just like pointer to this file. So if I change this file, it is going to directly impact this one and so on. So in the case of this one, I say I told you you should think of it as a copy of the original file, so it has the same inode. So if I delete this one, the inode is still there. If I delete this one, the inode, this one's inode is still there. And in the inode, I told you that it stores metadata information, right? So even in the inode, that you can still know how many links are pointing to this inode, specific inode. So let's see in practice. First of all, let me see if I have anything, any files. Alright, it seems that I don't have any file. So let me create echo file 1 contents into file 1 file. Alright, let me cut, so I verify it has been created. Alright, yeah, file 1 contents, it has been created. So I have this one, right? I have created a file. So in order for me to create, be it a hard link or a soft link, the command I am going to use is this ln. ln stands for link. For symbolic links, we have to specify additional argument to the ln command, which is s, and it stands for symbolic link. So link, create a symbolic link of this file, of file 1, and then call it link 1. Alright, let's run it. Alright, it's successful. Let me ls to verify. So link 1 exists. So what if I open the contents of link 1? Cut link 1. Alright, so file 1 contents. So it's just like I go to my Chrome shortcuts in the desktop that I created and opened it with the cut links. So what if I perform some actions in the Chrome? I'm just giving an example with Chrome, okay? So what if I create an example, like I write or change the contents here. Let's say echo file 1 more contents. Alright, write it to the file 1. No, I'm writing it to the distance, sorry, link 1 for us to see this in practice. Oh, not save, sorry, run. Wow, so it has added the file into the link 1. So it's the same way if we try to access the file, access it using the file 1. Let's see. File 1 is the same contents. It's just like pointer. This is just like pointer. It has different inode though. It points to that inode of the original file. So let's view this. Okay, let me create another more link. Okay, link 2, in order for us to understand this concept even more. So link 2, sorry, remember creating link starts with ln. Remember, we're symbolic link of file 1, and then let's call it link 2. Alright, that will create link 2 this thing. So let's ls all files in long format. Let's see. Alright, then let me push it this bit, so link 1, you see, it's pointing to file 1 directly. Link 2 is pointing, it's just like a pointer to file 1 also. So there's a way that we can print the inode, ls the inodes of the two. Okay, so 13 is the inode of file 1, 14 is the inode of link 1, 15 is the inode of link 2, and then these are just the essential for the current this thing. Alright, so let's keep this one in mind. So let me create a hard link. So in order to create a hard link, we don't need to add this additional attribute here. So we just say we will create a link for file 1 and then call it hard 1. Alright, let me create another one for file 1 and call it hard 2. Remember, I told you it is like hard links is different name of the same file. Like it's the same file that we are creating. It has the same inode number. It has the same everything with the original file. If we delete this original file, the links are going to work independently because they have the inodes. They point to the inode, like they have the metadata information of the inode. So let's see. Let's lsi here. You can remember the lsi, ls all the contents, the inodes of the contents here. You see, file 1 has an inode of 13. Hard 1 has an inode of 13 also. Hard 2 has an inode of 13 also. So the hard links are nothing but different names. They are like the same files that we are creating, and they can exist without the original file. Like unlike the symbolic links, if we happen to miss the original one, we are not going to get access through the link here. It's just like a shortcut in Windows, because if you create a shortcut of an app in Windows and then you delete the original copy of the file, then that link is not going to work. So I think that's it about Linux linking. I hope you've learned something. Thank you very much. Goodbye. Happy linking.